Welcome to qnawire.
So we know that the total energy of this equation, E, is 6 joules. And we also know that it should equal to the potential energy times the kinetic energy. So to make this problem looks more simple, also since we're looking for the amplitude of the vibration, which is not related to the kinetic energy, we should be assuming that we should be looking at the whole system at a point when the potential energy is at its maximum, which means we have no kinetic energy at this point. So it's going to give us E equals to U max plus 0, which is 6 joules. So we know that the maximum potential energy, which is when the displacement is at its greatest, would equal to 6 joules. And the equation of kinetic energy is 1/2 of k times displacement x. And since we know that the system is at its maximum displacement at this time, we should say that it's at the x is at a. So k times a squared. That's the maximum displacement. And then the only thing we need to do is to calculate a. So we times both sides by 2, 12 joules equals to k a squared. A equals to square root of 12 joules divided by k, and we can plug in k here, which is 1200 Newton per meter. And in the end, that calculation should give us 0.1 meter. And that's the displacement, which is the maximum displacement, also the amplitude of vibration of the system. For B, the variable we're looking at is the maximum speed. In order to solve that, we need to take another assumption, which is we need to look at the system when the kinetic energy is at its greatest, so that we don't have to worry about the potential energy. So now we have E, the whole the energy of the whole system equals to 6 joules, and equals to a k kinetic energy at its maximum plus 0. So now the potential energy is 0. So now we have the kinetic energy equation, 1/2 mv squared. And now the V is at its maximum, so we call it V max equals to 6 joules, because K max is directly equal to 6 joules, the total energy of the system. So now we can say that we can solve this equation in the similar way of how we did part A. So we times 2 by both sides. And V squared, V max squared equals to 12 joules. V max squared equals to 12 joules over m. And V max equals to square root of 12 joules. And m is, we need to do a conversion here because m equals to 55 grams. But the only unit we should use here is kilograms. So it's gonna equal to 55 times 10 to the negative 3. And we can also write it in 5.5 times 10 to the negative 2 kilograms. So 5.5 times 10 to the negative 2 kilograms. And that should give us the answer of something around 14.77 meters per second. That's the maximum speed. Now we can take a look at part C. which is pretty much asks us to combine part A and part B, and to find something that's when the position is at x is positive a over 2, and what the speed would be. So in order to solve that, we put out the energy equation again. So E equals to potential energy U plus kinetic energy K. And now, since we know that we have a displacement, but not at its maximum, so we can't really get rid of either U or K, but we need to incorporate both of the equations in order to solve the problem. So we need to write it this way. U is equals to 1 over 2 times K spring constant, x squared displacement, and also the K kinetic energy equals to 1 over 2 times m over v squared. And we know that the system of the equation is still the same, 6 joules. And we know that the spring constant, let's keep it this way so that it's less writing, but we know both spring constant and x displacement. And we also know the mass. So it's pretty easy and straightforward to solve this equation, because the only thing we don't know here is the velocity. Then if we times both sides by 2, have 12 joules times kx plus mv squared. And that will give us v squared equals to 12 joules minus kx squared. And v would just be mv squared. I've got m. So v would just be 12 joules minus kx squared divided by m and a square root. And now we can plug in all of the numbers we have. So 12 joules, I already have the number here. K equals to 1200 newtons per meter times x squared. We know that it's a squared divided by 4. And then we know m is 5.5 times 10 to the negative 2 kilograms. And since we know that A should be 0.1 from part A of the question, 0.1 meter from part A, we should also plug that in. And in the end, this giant thing should give us something about 12.792 meters per second. And that should be the final velocity of the question. And the question also asked us what assumptions we made in order to solve the problem. And we can clearly see that there's no energy loss we need to consider here. The potential energy and kinetic energy just transform from one another, and we don't consider things like friction or like air friction or anything like that. The only two energy here we're considering is just potential energy and kinetic energy.